Hey guys, welcome to the Code Pathshala. I am Roshan, working as a software engineer in F5. So today I'll be talking about the most important topic of system design, which is rate limiter. So what all things we will be covering in this video, the list is given here. So first we'll be understand about the definition of the rate limiter, then the benefits, then where to put the rate limiters. Should we put on server side or should we put on client side or should we put in middleware? So that we will discuss about. And then after the very important topic, which is algorithm of rate limiters. So these are the 5 algorithms. Then we will talk about the detailed design of rate limiting, how you will design the rate limiting in your organization, in your infrastructure. Then suppose if you want to scale your rate limiting to the distributed system, so how you can scale? So whenever you will be scaling, you will face the problem of race conditions. So how you can take care of those things. So we'll discuss about that. And then after at last monitoring, how you can monitor your rate limiter. So before starting the video, if you haven't subscribed this channel, please subscribe it now and press the bell icon. So without getting the delay, let's start the video. So the first thing that why we are using rate limiter. The rate limiter controls the rate of the traffic which is sent by the client or by the server. It means it limits the number of client requests allowed to be sent over a specific period. So suppose if API request count exceeds the limit which is configured in the rate limiter, the request will be denied and all the access will be blocked. So let's take the example. Suppose a user can post up to 10 times in a minute, or maybe you can allow 2 posts per minute. So for these things you can use rate limiter. Another example, that suppose you want to create 10 accounts per day with the same IP address. So I hope you understand the definition and the usage of the rate limiters. Now the next point is the benefits. What is the benefits of the rate limiters? So one of the most benefit of the rate limiter is that it prevents the DDoS attack. Like the Twitter limits 300 tweets per 3 hours and the Google Doc API limits up to 300 read requests per user per hour. It means per user per 60 seconds. So if request exceeds the limit, then the rate limiter will block those all requests which will be exceeded. That's why it prevents the DDoS attack. So the first benefit is prevent DDoS attack. The second benefit that it is reducing the cost. So suppose the company which is using the third party API and pay hourly basis for those APIs. In this condition we need to limit the request. So the cost will be reduced. So second benefit is reduce the cost. The third benefit, the rate limiter prevents the server being overloaded. It means that suppose if you are putting the rate limiter in between client and server, so you are putting the limits of the API calls and client will not cross those limits. So if the limit exceeds, the call will not going through the server. It will be blocked at rate limiter. Prevent server being overloaded. So this is the third benefits. So I hope you understand about the benefits of the rate limiter. Now the next point is that where we have to put the rate limiters. Should we put at client side or should we put at server side? So let's discuss about that. So one is that can we put at client side or maybe server side or maybe middleware. So suppose if you are putting the rate limiter at client side. So in this case, client request will be easily forced by malicious actors because you are a client and we are putting the rate limiters. You can cross the limits because you can change the things, correct? So you cannot put the rate limiter at client side. Now the point is that can you put the rate limiter at server side? Of course you can, but it is not recommended way. So suppose you are putting the rate limiter at server side. So in this case, for each and every client request should be connected to the server and then after rate limiter will work. So this is not the good design. If you are putting the rate limiter at server side, client must have to connect it with the server to get the benefit of the rate limiter. So now point is that where should we put? We can put in between of the client and server here. So let's see how we can put the rate limiter between client and server. So suppose here you have a client, you have a server and you are putting the rate limiter in between of client and server. So let's take the example that you are configured the rules or in the rate limiter that you can only allow 2 requests per second. So suppose in 1 second you will get request 1, then it will go through the rate limiter and reach out to server request 1. Now request 2 will come because you are configured 2 requests per second. So in the same seconds the request 2 will come, so it will be passed through the rate limiter and reach to the server. So now let's see, the third request will come in the same seconds. So here in rate limiter it will be blocked and it will not reach to the server. So the client server communications will not be done for the third request. It will be blocked because you have configured 2 requests per second. So whenever the third request will come, it will be blocked at rate limiter and return it to the client with the response code 429. That indicates that too many requests. So I hope you understand that where we should put the rate limiters. So now suppose if you think that should we put a separate service for rate limiter. So yes, you can put, or maybe you can put in the same code without writing the separate service. So it all depends that how your code is designed, what types of infrastructure you are using. So now we will be talking about the algorithms. The first algorithm is token bucket algorithm. So token bucket is a container with predefined capacity. So if bucket is full, then you cannot add any more token in that bucket. Each request for a separate user will consume one token, and it provides the separate bucket for every user. So if bucket is empty for that user, the request will be rejected. So every user has a separate bucket. When any request made for the user, we remove one token from the bucket, and after a particular time interval, the bucket will be refilled with the appropriate tokens. So now let's take the example. So if bucket capacity is 4 and we can refill the bucket with 2 tokens per minute. So here suppose if we have a client and it has 5 requests, and here suppose we are putting the token bucket. So here we have a bucket with a predefined capacity, and we have a client that will make the request. If everything is okay, the request will come to the server. So let's take the example. So suppose the bucket capacity is 3 and rule is 3 requests per user per minute. So if user make a call at 12:00, so at that time the bucket capacity is full. The request will take one token from the bucket and make the request. The first request will come to the server. So now the capacity will be 2. Now the user will make a next call at 12:00 and 10 seconds. So at that time the capacity is 2. So user will take one token from the bucket and make a call. Request will reach to the server, and after that the capacity will be 1. So suppose at 12:38 seconds another request. So at that time the capacity is 1. So user will take that token and make the call. Because it is passing the rate limiter, so the request will reach to the server. Now at 12:48 seconds another request from that client. So here bucket is empty because we already have used 3 tokens from this bucket. So it is empty. So if it is empty, then the request will be dropped. So here the bucket is empty, so request will be dropped with 429 error code. And then after 1 minute, it means 12:01:00, the bucket will be refilled. So total token will be 3. So we have a bucket. In that bucket, the token will be there, predefined token. So when any request will come from the client, it will take the token and make the request to the server. Now the bucket size will be decreased. Suppose initially it will be 3, then after first token will be taken, it will be 2. The next request took the token, so now it will be 1. The third request will come, took the token and go through the server. In the same minute, the fourth and fifth request will come. There is no token available in the bucket, so the request will be dropped. So if you are going to design the token bucket algorithm, so it has 2 parameters. One is bucket size and second one is refill. Suppose if you have a bucket here and you have a refiller that will refill the bucket. For each and every request, it will take 1 token per request. So this is the token bucket algorithm. Now there will be some pros and cons of token bucket algorithm. So if you are talking about the pros of token bucket algorithm, so it is easy to implement, it is memory efficient, and it allows burst of traffic in a shorter period. If you are talking about the cons, there is only one cons. I'm thinking like it has 2 parameters. So it is very difficult to manage these 2 parameters. So now the second algorithm is leaking bucket algorithm. So leaking bucket algorithm is also very simple. It is using queue. It means it is using FIFO system. So when any request will come, it is checking the queue. Is queue bucket is full? If bucket is full, then request will be dropped. If bucket is not full, then the request will be added in a queue, and then those requests will be passed to the server. In this example, we have 5 requests, and here we are implementing the queue mechanism, leaking bucket algorithm. So it is checking that each queue bucket is full. If it is full, then drop the request. If not full, then add the request into the queue. So when first request will come, request 1, the queue is empty at that time, so the request will be added because so the request will come to the first place. Now when second request R2 will come, it is checking because the bucket size is 3 here. So is it full? No, it is not full. So it will add into the queue, then increment the token in the bucket. So it will be 2. Now the third request will come. It is checking each bucket is full. No. Then it will add those requests and increment it. So it will be 3. And the bucket size is also 3. So when fourth request will come, it will check each bucket full. Yes, it is full. Then drop the request. When fifth request come, check bucket is full. So drop the request. And after a time interval, it will be reinitialized, means buffer will be empty. To implement this mechanism, we have to use two parameters. One is bucket size and the second is outflow rate. How many requests will be processed at a fixed period of time. So if we are talking about the pros and cons, so pros is that we can implement it easily and the requests are processed at the fixed rate. So it is stable. If we are talking about the cons, we have to maintain two parameters. And the second cons is because we are using queue. So if suppose the old request not processed because of any reason or might be the failed. So in that case, the new request will be rate limited, which is not correct. So the next one is fixed window counter. In this algorithm, we are dividing the timeline into a fixed size of window and we assign the counter for each window. When any request will come, it increase the counter by 1 and when counter reach to the predefined threshold, the request will be dropped. Otherwise, the request accepted and it will be reached to the server. So there is a major issue in fixed window counter. It allows more requests to go through at the edge of the window. So this issue will be fixed with the sliding window log. So in sliding window log, we are keep tracking the request of the timestamp such as sorted set of the redis. When any new request will come, we are removing the outdated requests. Outdated timestamp, it means those older than the start of the current window. Then we add the timestamp of new request to the log. If the log size less than equal to counter, predefined counter, then we accept the request, otherwise we reject the request. So the request will be dropped. Let's take an example. So suppose a new request will come at 10001. So at that time the log is empty. It means it will allow the request and this particular timestamp will be added to the log. And suppose the allowed count, it means the predefined count equal to 2. Next request at 10038 seconds. So it will insert those timestamp. And after that, it will check the log size, the counter. So the log size is 2 and the count is 2. So it means the log size equal to count. So it will allow the request. Suppose the next request will come at 10050. So it will insert the timestamp and then check the log size. So here the log size is 3. It means log size greater than count. So the request will be rejected. Now suppose the next request will come at 10140. So here the time range should be 10040 to 10140. It means whatever the request comes before that, it should be removed from the list. So this is the latest time frame. It means the older times will be removed, like 101 and 1030 will be removed from the log. So the timestamp list will be 1050 and 10140. 10050 and 10140 because 100 and 01 and 10030 will be deleted from the list because it is outdated. So the edge case will be covered with the sliding window log. So the next algorithm is sliding window counter. This is the hybrid approach with fixed window counter and sliding window log. Fixed window counter is not a robust solution, whereas sliding window log is a robust solution, but it enforces the hard time limit on every time window. So it is not memory efficient solution. In sliding window, we don't know that how many requests are in. So for this solution, we have to calculate the weightage of the previous time window. Then estimate that how many requests are in current sliding window. So assume the rate limiters allow 7 requests per minute. So you have 5 requests of previous minute and 3 requests of the current minute. So this would be 70%, this would be 30%. And this is the current time. So when new request arrives at 30% position of current minute, then we have to calculate the number of requests in the rolling window. And how we can calculate? So here is the formula. Request of current window plus request of previous window multiply by overlapping percentage of the rolling window and the previous window, which is 70%. It means 3 plus 5 into 70%. 6.5. And if we are rolling it up, so it will be 6. So currently we have a 6 requests and the limit is 7. So we can take one request here. So this is all about the algorithms which we will be using for rate limiting. There is some rules which has been written in the config file. So we have to understand those rules first. How we can write the rules in the config file. So suppose if you want to allow only 5 marketing message per day. So how you can write this in the config file? So to write these things in the config file, we have to write the descriptor for the rate limiter. So how we can write it? We can write it like this. So this is the format that we have to follow. If you can see this format, the first thing that we have to write the descriptors. So in the descriptors we have the key value pair. So the first thing would be key, then the second thing would be value. Key would be the message type, what types of rules you want to apply. The value will be the string like that, what types of value it would be. So in the rate limiter we have two things. One is the unit, so in which unit you want to measure these things, and the second thing that request per unit. How many requests per unit you want to allow. In the current example, 5 marketing message per day. So the key would be message type because you want to get the message. So value would be the string, what types of value you want. So here the value would be the marketing, you want to get the marketing message. So the key would be the message type and the value would be the marketing. So here we have to put the unit, how you will measure it. So here the unit would be day because you want to measure it in a day, and the request per unit, what is the rules. So you want 5 marketing message per day, so it would be 5. So if you can see these rules, it will completely show what types of message you have and what is the rules you want to apply it on. So what we have written here, 5 marketing message per day. So this is the rules. Let's take another example. Suppose if you want to allow the user to be logged in only 5 times in a minute, means user can log in only 5 times in a minute. So how you can write it? You have to write first descriptors, then you have to write the key. So what would be the key here? What types of rules you want to apply? So it could be like auth type. Previously it was message type because you want to receive the message, but here you have to do the authentication things because user are going to logged in. So it is the part of authentication. So it would be auth type. What could be the value here? So the value could be login because you want to check the login. Now the part is rate limit. So in rate limit we have a unit and then we have a rate per unit. What would be the unit here? Because you have to check in a minute, so unit would be minute. And what would be rate? So rate would be 5. 5 times in a minute you want to verify. So this is the rules, and these all rules are written in a configuration file, and this config file is stored in a hard disk. Anytime if any request is getting rate limited, the rate limiter will send the response code 429, which is too many requests. So this is all about the rules. So let's discuss the next part. So now we will talk about the detailed design of the rate limiter. So this is the detailed design. In middleware you can see here the rate limiter is there. So what we are doing, we are writing the rules that we already have discussed right now. We are writing the rules in hard disk. So the rules will be written in the hard disk drive. Then we have the workers. So workers will get the rules from the hard disk and put it into the cache. So in that way, the rate limiter does not has to reach to hard disk. So the communication will be so faster. So this is the job of the worker. Worker will get the rules from the hard disk and put it into the cache. Then, so here we have the API server. Whatever the request is passed through the rate limiter, the request will come to the API server. Now we have the Redis. The rate limiter fetches the rules from the cache, and it also fetches the data like timestamp and counter from the Redis. So here in Redis we have timestamp and we have a counter. So these data will be fetched from the Redis to rate limiter middleware. Then it will apply the rules, do the calculations, and then it will decide that either we have to pass this request to the server or we have to drop this request. So whenever the rate limiter will drop the request, means any request is rate limited, in that case we have two options. So rate limiter has two options. The option number 1 is it will drop the request and send back the response code to client, and the response code will be 429. It means too many requests. What is the option number 2? Whenever any request is rate limited, rate limiter will choose the option number 2. If any message queue is available, means we implemented the message queue. So what it will do? It will put the request into the message queue. After some time, on the base of the FIFO system, the message queue will be passed the request. So whatever the request comes first, it will out first. All the requests which is rate limited, it will put into the queue. And then after some sometime this queue will be processed. So now suppose if you want to scale this rate limiter to the distributed environment, while you will scale it, you will face some problems. Let's see. So what we are doing here, we are just getting the data from the Redis. So suppose Redis will return here X. So in rate limiter, it is checking is this data exceeds the threshold. If it is, means suppose the threshold is Y. So if X is greater than equal to Y, if yes, then we don't have to do anything, and then request will be rate limited. Suppose if it is correct and it is passed, so in that case what we are doing, we are increment this data X plus 1. So see the problem. Suppose two threads, two concurrent request is coming at the same time, like this. So see here the request 1 will come. So suppose the original counter equal to 3. So request 1 just gets the counter from the Redis. So the counter would be 3 and it will increment it. So before incrementing, request 2 comes and check the counter. So it will get the counter from the Redis, which is 3. Then after request 1, update the counter into the Redis, which will be 4. Here after that, request 2 will update the counter to the Redis, which will be 4. But it should be 5. So this is the issue. So this is the race condition. So we have a solution to fix this problem. The first solution would be implement lock. You have to implement the lock in between the requests. Whenever first request will come, it will lock the Redis, get the data from the Redis, then manipulate those data, increment it and put it into the Redis, and then unlock this one. So this process will take time. So it is slow. So while you will use lock, your performance will be degraded. So that is not preferable. So now you think that how you can fix this then. So you want to fix it and you don't want to degrade the performance. So for that you can use either the first approach is Lua script and the second approach will be sorted set of data structure that you can use. So if you are using the Lua script, in this case your performance will not be degraded and Redis will not support any other command while Lua script is running. It means Lua script will running in atomic mode. Now suppose if you want to scale your system for millions of users. So if you want to scale your system for millions of users, one rate limiter is not enough to handle all the traffic from those users. To fix those things, you have to use multiple rate limiter servers. So now let's take an example. Suppose if you have two rate limiter servers, rate limiter 1 and rate limiter 2, and suppose there are two clients, client 1 and client 2. So you want the client 1 should use rate limiter 1 and client 2 will use rate limiter 2. But it's not possible. It might the client 1 will use the rate limiter 2 and client 2 will use the rate limiter 1. So there is an issue because the rate limiter 1 does not have the data of client 2 and the same as the rate limiter 2 does not have the data of client 1. It doesn't have the data. So how you can solve this problem? This is a synchronization issue. So the one possible solution that you can use the sticky sessions. So if we use the sticky session, the client will send the traffic to the same rate limiter, but it is not advisable because it's not flexible and you cannot scale it. So now the point is that what you have to use. So the final solution would be that we can use the centralized data store like Redis. How it will be designed? Like client 1. So to fix those things, we can use the centralized Redis, which is the centralized data server. So the rate limiter will use the same Redis server, the second rate limiter will use the same Redis server. Both rate limiter will have the data of client 1 and client 2. So this will fix the issue and you can scale the system up to the mark, whatever the scale you want. So now the last point is monitoring. So while you are developing a rate limiter server, which is a huge scalable system, to develop those things you have to monitor your system. Why we need monitoring? So suppose if you are putting many rules, so some rules will so strict, in that case your actual request is getting rate limited, and sometimes you feel that your rules is not so strict, so many requests which should be rate limited, it is not getting rate limited and it is passing the rate limiter and reach to the server. To handle those things you have to implement monitoring, and while you will do the monitoring you have to put the log and matrices. So here Elasticsearch and Grafana will come into the picture. This is all about the rate limiter. So now we know everything about the rate limiter, how you can design the rate limiter, where we should put the rate limiter, should we put it at client side or server side or in the middleware, what all algorithms should be used for the rate limiter. Then detailed design we already have discussed about that. and the rules, how you can define the rules of the rate limiter, and then why we need monitoring of the rate limiter server. So I'll put the link of the handwritten notes in the description. So if you haven't subscribed this channel, please subscribe it now. If you like this video, please hit the like button. I'm signing off. Thank you. Bye bye.